Welcome all to today's lecture. Myself Tukur Gupta. I am Assistant Professor in AKGEC Engineering College, Ghaziabad, and I am covering the lectures for microprocessor and microcontroller subject. Code is AKGEC 502 and which is being taught in 5th semester. So in this lecture I am covering the timing diagrams of 8085. So the first timing diagram that we are going to study is that of memory read machine cycle. It is used to fetch 1 byte from the memory. It requires 3 T states. It can be used to fetch operand or data from the memory. During T1, A8 to A15 contains higher byte of address, and at the same time ALE is high. Therefore, lower byte of address A0 to A7 is selected from AD0 to AD7 as shown in the figure. I'll show you the figure. Since it is memory read operation, input output oblique memory goes low because memory is the active low part. During T2, ALE goes low, read signal goes low, the address is removed from AD0 to AD7 and the data D0 to D7 appears on AD0 to AD7. During T3, data remains on AD0 till RD bar is at low signal. So let's have a look on this timing diagram. You can see the first and the S1 is 0, 1 and S0 is 0 here. Then A8 to A15, the higher order address is latched. Here it is unspecified. During the first T1 state, lower order address is latched with the lower order address and data bus which is multiplexed, and during this ALE is high. Read is deactivated here and memory read is also deactivated. Now during T2, higher order address is latched as it is, but lower order multiplexed address and data bus is available to carry the data, and during this ALE signal is low. Read operation is activated, that's why the read signal is activated, and memory read is also activated. So this indicates the unspecified state. So in this way, this completes the timing diagram of memory read. Now, next machine cycle is memory write. It is used to send 1 byte into the memory. It requires 3 T states. During T1, ALE is high and contains lower address A0 to A7 from AD0 to AD7. A8 to A15 contains higher byte of address. As it is memory operation, input output oblique memory bar goes low. During T2, ALE goes low and write bar goes low because it is active low signal and it has to be low for activation, and address is removed from AD0 to AD7 and then data appears on AD0 to AD7. Yes, as I'll show you the figure also. Data remains on AD0 to AD7 until write signal is activated. Let's understand this using this diagram. We can see S1 is 0 and S0 is 1. This is the condition of write operation. Input output oblique memory bar is, since this is the memory operation, so it is low for activation. A8 to A15, these lines are used to latch the higher order address bus. AD0 to AD7 is used to carry the data to latch the lower order data, to latch the lower order address during the T1 state. And these same signals, same lines are used to latch the lower order data during the T2 state. Again, during the T1 state, ALE signal is activated, is high during the latching of lower order address, and write signal is deactivated. During the reading of the data, writing of the data, the write signal is activated. In this way, this completes the memory write timing diagram. Timing diagram of input output read. So this operation is related to the input output devices, and this is the read operation. So basically it is used to fetch 1 byte of instruction from an input output port. It requires 3 T states. During T1, the lower byte of input output address is duplicated into the higher order address bus A8 to A15. So this is an important point, we have to notice it. ALE is high and AD0 to AD7 contains address of input output device. Input output oblique memory bar. Here this is active low and this is high. So it will go high as it is the input output operation. During T2, ALE goes low, read goes low, and data appears on AD0 to AD7 as input from the input output device. During T3, data remains on AD0 to AD7, and till what point it will remain? Until the read signal is low. Let's understand this using this diagram. Here S1 is 1 and S0 is 0. This is the condition for reading. Again, input output oblique memory bar. This is the input output operation. That's why this signal is 1. That is, the state is high. If it had been a memory operation, then it would have gone low. A8 to A15. These lines are used. These are used to carry the higher order address. During T4, this is unspecified, and again this is latched. Now, AD0 to AD7, lower order address is latched during the T1 state, and this is latched when the ALE address in latch enable, this pin is activated. After the T1 state, these multiplexed address and data lines are used to carry the data D0 to D7, and during this address latch enable is deactivated, because now AD0 to AD7, these lines are used to carry the data, not the address. During the T1, read signal is deactivated, and after T1 it is activated, and it will remain activated until the data is present on the data bus. This signal is a combination of input output oblique memory bar and read operation. So input output read, this signal is activated after T1 cycle and will remain activated until there is the data present on the data bus. Next timing diagram which we are going to study is input output write. This operation is used to write 1 byte into input output device. It requires 3 T states again. During T1, the lower byte of address is duplicated into higher order bus A8 to A15. As shown in the figure, ALE is high and A0 to A7 address is selected from AD0 to AD7. So these are the multiplexed pins. And these are used to carry the lower order address. As it is an input-output operation, input-output oblique memory bar goes low. During T2, ALE goes low. Right bar, this should be, this should be high. Yes. So during T2, ALE goes low, right operation goes high, and the data appears on AD0 to AD7 to write the data into input-output device. During T3, data remains on AD0 to AD7 until write bar is low. So in this way, the write operation is completed. Let's have a look on this. So S1 is 0 and S0 is 1. This is the condition for write operation. Input-output oblique memory bar, this is high because it is presenting the input-output operation, which is active high. Again, A8 to A15 higher order address is latched on the higher order address bus, and this lower order multiplexed AD0 to AD7, this bus is used to carry the lower order address during T1 state. And after the T1 state, this multiplexed AD0 to AD7 bus is used to carry the data. During T1, ALE signal is activated and the lower order address is latched as long as this ALE signal is activated. After T1, this signal is deactivated. Same is the case with write operation. During T1, write is disabled because no write operation is being performed, and after T1, this write operation is being performed as long as the data is latched to the bus. So in this way, this completes our input-output write timing diagram. So today we studied that the types of machines, basic machine cycles, these are opcode fetch, next is memory, write, next is memory read, next machine cycle is input-output write, and input-output read. So in this way we complete with all the basic machine cycles. And the few things that we have to keep in mind while drawing the timing diagrams is that we have to remember that how many T states are occupied in these machine cycles. Next, we have to show the status and control signals, that is the input-output oblique memory bar S1 and S0. Then we have to latch the lower order address bus during the T1 state. After T1, this multiplexed address and data bus is used to carry the data. Higher order address bus is used to carry the higher order address, and after the read and write operations are to be shown. So in this way, this completes the timing diagrams. So it is just easy and crisp to draw, but we have to remember that what all signals are activated or deactivated at what point of time. So this is the art of drawing any of the timing diagram. If we know how many T states, how many bytes a particular instruction takes for execution. That's all for this lecture. Thank you.